Welcome back to the Essentials of Science. Today we're learning about mass. Mass is a property that matter possesses. An object's mass is a direct result of how much matter it is composed of and what type. Let's tackle that first part of the statement, how much matter it is composed of. What is the difference between two identical substances that have different weights? The heavier one is made of more atoms. It contains more matter. That's what gives it more mass. You can think of mass as a measure of how many atoms something is made of. Atoms are tiny, so this isn't very practical, but it is very literal. There's a second definition of mass, which is the resistance to acceleration when a force is applied. This is yet again a direct result of how much matter a material is made from. It's harder to push a car than it is to push a shopping cart, because the car is composed of a much greater amount of matter, meaning it has much more mass. If you have two identical substances, but of different weights, and you apply the exact same force to both, the heavier object will move less distance in the same amount of time. That's physics. Now let's discuss the second statement, which was how mass is also a direct result of what type of matter a substance is composed of. Why does a chunk of aluminum weigh less than an identically sized chunk of iron? Because it's made of different atoms. Last time we learned that all matter is composed of atoms, composed of protons, neutrons, and electrons. An object's mass, and therefore its weight, is determined by the number of protons and neutrons contained in the atom's nucleus. Electrons have a mass almost 2,000 times less than that of protons or neutrons, so we ignore them. As you can see, the aluminum atom contains fewer subatomic particles, protons and neutrons, so it has less mass. If we had a trillion aluminum atoms and a trillion iron atoms, we would find they have different masses. The nice thing about mass is that it does not change. Take a material and heat it up, and its mass remains the same. Cool it down, and its mass remains the same. Squish it, push it, pull it, twist it, bop it, and its mass, the number of atoms it contains, remains constant. As long as you do not add or remove from the material, you can change any physical property it has, but its mass will always remain the same. But don't objects weigh less on the moon? Yes, but that's weight, which is different. Weight is a force that an object exerts as a result of gravity. Your weight presses you into the earth. Hence, your weight is you applying the force. All objects with mass exert a gravitational attraction to all other objects that have mass. The moon is much smaller than Earth. It has a weaker gravitational attraction. It cannot attract an object with as much strength. Therefore, objects on its surface weigh less, because the force of gravity exerted on them is weaker. Both mass and weight can be measured in grams or kilograms, so this can be confusing. Here's how I think of it. Mass is how large or small something is, and weight changes depending on where you are. Like I said earlier, you can think of mass as how many atoms something is made of. When I think of, a kilogram of water versus 2 kilograms of water, well, 2 kilograms is more, so it's larger. That just makes sense to me. We are going to cover measurements in the next few videos, but we will do a sneak peek right now so I can illustrate a point. What the heck is a kilogram? It has a bunch of definitions, but here's the simplest. Well, it's not that simple, but whatever. A centimeter is a distance. Take a centimeter and cube it, and now you have created a volume that is 1 centimeter cubed. This is what we call a milliliter. 1 cc or 1 milliliter of water has a mass of 1 gram, which means that a liter of water at a specific temperature, that is, has a mass and weight of exactly 1 kilogram. Cool. But there's another way to define the gram, which again is 1,000 times smaller than a kilogram. A gram is the mass of 6.022 times 10 to the 23rd subatomic particles. This is called a mole, and it's just a number, like dozen, but a really huge number. Most hydrogen atoms are composed of just a single proton and an electron, but remember, we ignore the mass of the tiny electron. If you look, the mass of hydrogen is approximately 1. Helium contains 2 protons and 2 neutrons, and its atomic mass is approximately 4. This mass is derived from what if we had a mole's worth of these atoms? See, mass is a quantitative property derived from the amount and type of matter something is composed of, which is also to say how many subatomic particles are the atoms of that substance made of. Next time, we will start covering measurements beginning with length.